Good morning. Good morning, everybody. Namaskar. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking for Bharat India on this day, February 7, 2022, Monday, 3:43 a.m. मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ। आज फरवरी 7, 2022 रविवार आपके सामने उपस्थित हाजिर अपनी बातचीत को दोहराने के लिए, जो मैं दोहराता रहा हूँ और जब तक कोशिश करूँगा कि it continues. Topic is same as usual. I'm just trying to show you various files that are going to be conferred with, discussed in this talk. All important files. Before that, you can see this topic, as you know, it is regarding quality works. Quality works, coordination, engineering, communication, concrete materials, and engineering. We can say civil field engineering and other field engineering, engineers, contracts, safety designs, construction. Well, you can say miscellaneous types of activities. Those all are conducted on projects. जो भी हम प्रोजेक्ट पे काम करते हैं, ये सारी एक्टिविटी जनरली इसमें आती हैं। थोड़ा हिंदी में भी बोल रहा हूँ ताकि हिंदी अब कोई हमारे देश की भाषा नहीं है, औरों में भी चलती है। मुझे इस बात का भी गर्व है, जिस तरह इंग्लिश काफ़ी देशों में चलती है, हमारी हिंदी भी काफ़ी देशों में चलती है। शायद वो वर्कर्स क्लास ही सही, चलती तो है, पूरे गल्फ़ में चलती है, मिडल ईस्ट की काफ़ी कंट्रीज़ में चलती है, पाकिस्तान में चलती है और कई जगह चलती है। इसलिए थोड़ा थोड़ा हिंदी भी मैं कोशिश करता हूँ कि कुछ लोग अगर चाहें तो सुन सकते हैं। सारी बात तो नहीं आएगी, थोड़ी थोड़ी आ सकती है। हाउएवर, फिर भी मैं कहूँगा कि मेरा जो ये नेम प्लेट आप देख रहे हैं, मेरे दरवाजे पे भी लगी है, अभी थोड़े दिन पहले लगाई है कि लोगों को पता तो होना चाहिए कौन रहता है। इसमें आप देख सकते हैं suraj_engineer@yahoo.co.uk. You can see this name board in which my email address is written as suraj_engineer@yahoo.co.uk. It's nothing very specific, but just every day I try to tell suraj_engineer @yahoo.co.uk, and my professional registered title is FIE, that is Fellow of Institution of Engineers India, and Chartered Engineer India, which is linked to FIE or MI or AMI, so I am FI. So my first membership is FIE, that is this institution, which is Royal Charter. Its charter was granted to it in 1935, which is a part of Constitution, you can say, because Constitution itself is a charter of this country. And International Professional Engineer India, this is an additional certification that I got based on my experience, my attainment, and my keeping myself update on what happens in engineering, and that title is International Professional Engineer, or you can say another title is also there, that is Professional Engineer India. Both titles can work together. International happens when you have got international exposure on works in engineering, and that's really important. Either you have got international practice, or you have got international exposure, or you have worked, or you can see, you understand what happens in this country and the other country. Now, however, all codes work in engineering. You cannot say that your code works. No. When you work here, or you work in America, or you work somewhere else, you have to work with all procedures. Though we are not very serious in our country, but even our codes are not original. We have combined, amalgamation of these codes from various countries. So it doesn't matter. As far as we comply with codes, we can say that we have our own codes, but in engineering, there is no independence of codes. You can use your code, American code, European code, other codes, our codes, whatever, doesn't matter. As far as we rely on works, we have प्रोडक्शन ऑफ क्वालिटी एंड कोऑर्डिनेशन। जब तक हम अच्छा गुणवत्ता का काम देंगे, अच्छा हम कह सकते हैं समन्वय रखेंगे, चाहे हम अपने देश के कोड यूज़ करें, जो कि हमारे पूरे अपने नहीं हैं, हमने भी तो दूसरे कोड्स से उसको एमलगेमेट किया है। इसलिए जहाँ तक कोर्स एक तरह का नियम होता है इंजीनियरिंग में, मैं आपको समझा देना चाहता हूँ कोर्स क्या होते हैं। एक तरह का नियम होता है हमारे हमारे इंजीनियरिंग में। और ये जितने भी हम रजिस्ट्रेशन की बात कर रहे हैं, इंटरनेशनल प्रोफेशनल रजिस्ट्रेशन और दूसरे जो भी होते हैं, ये वही होते हैं कि यू अंडरस्टैंड एवरीथिंग इन इंजीनियरिंग, मीन्स यू कैन अप्लाई दिस कोर्स, यू हैव एक्सपीरियंस एप्लीकेशन. If you are a chartered engineer, you have must have capacity to do that, to understand that. If you are a fellow or member, means you are a competent person to handle this course, to apply this. And you see, engineering does not stop just at when you have passed it. Actually, it doesn't even start after passing. Means it starts when you work in profession, you work in field, in whatever capacity you can say. You have to work in field in whatever capacity. It only then starts. It doesn't start, just at whatever time. If I don't work, or whosoever is concerned, if you don't work in profession, I mean to say whether you are in employment or you are having your own practice, whatever you are involved with engineering, and engineering means life. And engineering means do something concrete, because engineer is full of facts. Until you can say you don't have any experience, you don't have any, you can say, involvement in profession. If somebody say, I just did effort, somebody passes engineering degree or whatever other degree in engineering, and you don't work, you don't practice engineering, you don't do job, in that case, हम कह सकते हैं, we can clearly say this person is not involved in engineering, because just getting academics based degree, it may be diploma, it may be degree, it may be master's, it may be doctor, if you don't work, it doesn't mean anything. Because engineering is not taxed itself, it's not taxed. Engineering is not syllabus. Engineering is something to produce, something to do. And if you just say, no, I got this degree and I'm engineer, okay, you may be engineer in certification form. It doesn't mean anything. In certification form, you are engineer. And you're happy with that, okay, fine, you remain happy, it doesn't matter. As far as you're happy, that's fine, but it matters only if you are involved in her, then that's more important rather than this. So what I am to say, those in engineering profession particularly, and also in medical science, if you don't practice as doctor, you can't say I'm doctor. Because you won't learn anything, and by professional like practice only, you know, or you apply your knowledge. And you know what your knowledge you have, you can apply it correctly, means you know about that. I'm just trying to say, profession means you keep working. It's not politics, it's not where no mind is used, it's not other fields where professional working is not acceptable. But when you say it is professional course, it is professional degree, it's professional practice, this means you have to, first of all, it's your duty to keep yourself update of what's happening in that profession, what's happening in your branch or your discipline subject. Every day technologies keep changing, minds keep changing, and engineering means use of mind, use of whatever knowledge you got, and application of that knowledge, and further research on that means further operational research. When I do concrete, I know what problems I did face and how these problems could be avoided. That's my job, to know it and to apply that. It's not only myself that I have to do that. All workers who are associated with me, it is also their job, and I have to learn from their practice, their work, efficiency, quality, methods they use, and even they are not very qualified, highly educated, but they deal with as technicians, I can say. Every worker in engineering is a technician, because that worker applies technology. It may be even mason, carpenter, helper, or concrete gang people, or electricians, plumbers, duct workers, welders, whoever they are. They all deal with technical work, engineering work. Of course, it is at lower level, or it's, you can say, item related, but it is question that it's an understanding that they involve themselves in production activity. And if they do not involve, engineers cannot do anything. That is also a fact. ये भी सच है कि अगर हम अपने वर्कर्स को, जो हमारे साथ काम करते हैं, राजमिस्त्री हो, कारपेंटर हो, बढ़ई हो, लोहार हो, या आप कैसे सरिया फिक्स करने वाला हो, वेल्डर हो, बिजली वाला हो, डक्ट वाला हो, एसी वाला हो, जो भी कोई है, प्लम्बर हो, वो सब हमारे टेक्नीशियन है, हमारे कह सकते हैं आप एक छोटे लेवल के, एक तरह के वर्क इंजीनियर हैं, जिनके बिना अगर वो सही काम नहीं करेंगे तो काम सही नहीं होगा। और हम हर वक्त तो कोई भी इंजीनियर पूरे समय तो उनके सर पे नहीं हो सकता। और सच बात तो ये है कि इंजीनियर भी उसी काम को देख के इंजीनियर बनते हैं। काम वो सही करते हैं तो प्रोसीजर पता चल जाता है, और वो लोग जानते हैं काम, क्योंकि वो सीखे हुए होते हैं, चाहे वो पहले से सीख के आए हों अपने परिवार की वजह से, या वो ट्रेनिंग लेके आए हों। इसलिए उन लोगों के काम की वजह से ही आगे काम चलता है। सच तो यही है। वो अलग बात है कि उनको ट्रेनिंग दी जाती है, समझाया जाता है कैसे होता है, और थ्योरी नहीं समझते, कोई बात नहीं है, लेकिन काम तो समझते हैं। थ्योरी हर एक तो नहीं समझ सकता, कॉलेज हर एक हमने नहीं जा सकता। इसलिए हमको ये चीज़ समझनी होगी कि एक क्वालिटी लाने के लिए, एक समन्वय लाने के लिए हमको सबको साथ लेके चलना पड़ता है। अपना छोटा स्टाफ, छोटे वर्कर, बड़े वर्कर, प्रोफाइल वर्कर, और यू कैन से ट्रेन वर्कर्स, जो भी आप कह लीजिए, इंजीनियरिंग में बहुत कुछ होता है। और सच बात तो यह है कि इन लोगों से जो कॉलेज से ट्रेन नहीं है, जिन्होंने एक्सपीरियंस लिया है, हो सकता है उनकी भाषा अच्छी ना हो, उनके सोचने का तरीका अच्छा ना हो, और हम कहते हैं जुगाड़बाजी, जैसे हम कहते हैं अपनी भाषा में, वी हैव मैनी अरेंजमेंट्स, प्रैक्टिकल अरेंजमेंट विच इक्वल टू in translation words, you can say jugaad, you can sometimes say we don't know what to do, but this person arranges something, you can say occasional arrangement without any form. If you can arrange something which has got no form or no procedure, or you never expected that, but some person does it in requirement time, or there's certain requirement or emergency, and it continues working, and that's also called a kind of ad hoc arrangement, and that can become a part of your practice, a cooperative method. So a jugaad, we call it our language, or you can say just think without thinking. By operational working, you get solution. Something is broken, for example, and immediately somebody starts it by its hook or trial, and it works for time being. We can say it is a kind of experience. One used mind and got it. So I'm just referring to it because it's very important in engineering. Engineering actually means use of mind. Many times I have referred to engineering means you have to learn, you have to use, you have to check, you have to apply, you have to further learn, further check, like this. Just like we say in organization or management, plan, do, check and review. We have to plan something, we have to do something, we have to check that thing which we did, and then we have to improve on again same work which we did. And that is the reason I have included many titles here, though these are all one title, and that's quality or system of working. You may call it all, because we design something, and before designing we plan something, or we provide budget for that, and we design it. And design is also in many sections, which can be, you can say, plan design, which we call feed, means what we have to design, what's our conception, then goes to detailed design, and then further detailed design, and then goes to contracting world, where we say bidding is important, and bidding process goes on, then awarding process goes on, and then you can say construction stage comes, or you can say design stage and construction stage, all are there involved. And these are all called engineering activities, engineering subjects or engineering domains, and these are actually very important from public point of view. That's why I'm trying to talk to people of this country and all over the world, that engineering is not only for engineers, but this is for you. Engineering is for you. I'm not saying you learn everything, but at least we should know, people should know what we are doing, how we are doing. We cannot, you see, just like a doctor treats a patient and patient knows about doctor, same way a law is handled by a lawyer or advocate, and justice is delivered through court. And likewise, people know about chartered accountant, people know about company secretaries, people know about nurses and pharmacists, and whoever professionals there are in field. All are public oriented. But of course, people know there are engineers, but people do not know what is engineering practice. They only see some project and say, okay, this is engineer product done by some engineers. Okay, that's fine. But is that enough? My point is that enough work we have to understand this point, that we cannot go without people knowing what we are doing. We fence our construction project, we keep aside, people should not, that's only from safety viewpoint, but people should know what is our role. People know how films are, how produced, how trains are available, flights are available, but background, it's not clear to common people. It's clear only to those who are involved in that field, who practice that field. So it's very important point we have to be clear about, and that's only reason we talk a lot on our engineering platforms on deliberations or seminars or webinars. But that is too limited, very, very small talks we conduct there. Some person talks for 10 minutes, some talks for 15 minutes, some talk 20, half an hour maximum. It doesn't give anything specific. Okay, we attend that, that's a practice, but we should talk to people in clearly detailed terms. People should know, because if people are made aware, they can understand meaning of quality. Or they will always say there's no quality, everybody is thief, and still they will say like this is generally said in this country as well. Oh, civil engineer तो ऐसे होते हैं, वैसे होते हैं, ठेकेदार ऐसे होते हैं. They call like this, contractor are not good, engineers are not good, because they don't care for the, वो खा गए जी, वो ये कर दिया, सीमेंट नहीं डाला, ये still so many talks are there which have got no real meaning. This is only just an assumption. And this is our duty as engineers, to educate people, because engineering is meant for them, not for us. To be very frank, we are operatives of engineering, we are operatives of construction, we are operatives of design. To be very frank, we are not users. Our production is used by people. So those who are clients are people, owners for property they would be, our clients, and they should be happy with work. And actually they do not know what is there inside. Something is hidden, every structure is hidden, the structure is hidden, all finishes are visible. You can see plaster, you can see painting, you can see decoration, that you can see beautiful doors and beautiful stonework and beautiful flooring, and all that we can see. These are all visible, but behind that there is something else, and that is a structure. If a structure doesn't work, these finishes cannot work. And that's where I am trying to let people know the meaning of structure, because they confuse themselves. And I'm not plan to criticize someone. The question is, a structure is a structure. It's a kind of body which it takes all these loads and forces which govern structure. If a structure is good, your every you can say item which goes onto that, for example, plaster or flooring or whatever, and use of that structure by people, that would be successful. And it is therefore very important to understand this point, why we talk of quality and why do we talk of coordination and communication. And this is an only requirement to meet, and that's why I say in our country we have to think about that. And thinking doesn't cost anything except that it gives a solution. And thinking is not done by everybody. Engineer's duty is to think. Engineer's basic duty, fundamental role of engineer is to think, and we have to define this role ourselves. Nobody can define for us. We cannot expect a definition by law, because law doesn't understand what engineering is. We understand engineering. And we are not slaves to law, we are slaves to work. And engineering itself is a law, all acts are involved, all you can say codes are involved, all procedures and formula are involved. A lot of work has been done, many subjects are available in every branch of engineering. Say in civil engineering, you have to read at least, study at least 30 to 35 subjects, and all relate to engineering work. So everybody is learned one. We have to realize this fact, that we have to apply engineering knowledge and not commercial knowledge only. Yes, commercial knowledge is important, but first engineering knowledge should be realized. If we realize engineering knowledge rightly, we can say, okay, commercial, fine, it is commercial. After all, it is to be sold, some products will be sold. So that is different issue. We know economics of that, we know commerce of that. By virtue of experience, we can understand, because we spend money on works. And that money itself is investment, and then we have to get back that investment also in terms of transactions of business. So it is different. Means first is technical work. If you do not work, if you do not produce, there is no question of commercial on that. And that is only reason I try to talk in this way, particularly for engineers' considerations, because I have experienced that 98%, 95% engineers at least bother about commerce. I mean, they say, okay, let it go as it is, and let it go as it. Attitude doesn't work. Engineering means thinking, concentration, thinking. Because if you, of course, if you have objective, if an objective to achieve, this works. If you don't achieve that, if you don't do that, it won't work, and that is important point. I won't say that only I am telling. I think all engineers think this way, and that thinking is really very important because thinking forces us to think further. You know, when you start working, maybe you're not interested that time to work. What happens? Psychology actually it is, and you start working on that. If you had some strain in your body, of course it starts then leaving you, and you get back to your prime power, and you keep on working further. After a few minutes of working, you think you are freshened yourself. It happens. अरे हम काम नहीं करना चाह रहे थे, थके हुए थे भाई, लेकिन क्या हो गया पता नहीं। मैंने कहा थोड़ा काम करते हैं, थोड़ा थोड़ा सही। और जब दोबारा काम शुरू किया तो आहिस्ता आहिस्ता मैंने देखा कि थकावट चली जाती है। अब फिजिकल थकावट रह सकती है, मैं उसकी बात नहीं कर रहा। जो माइंड में एक था भी, यार छोड़ो, बहुत बोर हो गए करते करते, सुबह से इतने घंटे कर रहे हैं, थोड़ा सा रिलैक्स करते हैं। और रिलैक्स भी आप नहीं कर पाएंगे, ये भी पक्की बात है, क्योंकि इंजीनियर रिलैक्स ही नहीं कर सकता। ये भी एक, शायद आप इस बात को मानेंगे नहीं, हूएवर इज रियल इंजीनियर, जो वास्तविक इंजीनियर है, वो रिलैक्स नहीं कर सकता मेंटली। जब तक प्रॉब्लम हाथ में है वो रिलैक्स कर ही नहीं सकता। वही इंजीनियर का आत्मा होती है, वही इंजीनियर की एक डिटर्मिनेशन होती है। शायद वो आत्मा उसको उस रास्ते पे ले ही नहीं जाती जहाँ सोया जाए, और वो सो भी गया गलती से तो सपने में भी उसको भूत प्रेत ही दिखेंगे उस प्रॉब्लम के, और वो प्रॉब्लम तो सॉल्व जब तक नहीं करेगा वो शांति से लेट नहीं सकता, क्योंकि एक बार प्रॉब्लम सॉल्व हो गई तो फिर तो चलता रहेगा। इस बात को थोड़ा समझना होगा। वी हैव टू अंडरस्टैंड दिस, दैट इंजीनियरिंग मीन्स वी हैव टू डिस्कवर, एंड डिस्कवर डजंट मीन इनोवेशन। डिस्कवर मीन्स वी हैव टू फाइंड सॉल्यूशन दैट इज इन कवर. And of course, there is a power that helps every engineer, and that power is a universal power, and that power is soul, or that power is God's gift, God's blessings. Engineering means God, because we cannot deny this fact. And somebody says, "No, I don't believe it." It's not dependent on your belief that God exists. The God exists because you exist. Simple. We cannot contravene this fact. If I exist, we exist as human. All creatures exist, this world exists, means someone is there, and that one is God. Even I can't see that. No problem if I can't see, but it is working, it is effective. Yeah, I'm not in my own control. I'm not in my own control. I cannot decide my death, I cannot decide my birth, and no one can do that. This means we are having no controls on ourselves, and this means somebody else controls us. I can say that's God. And same thing I refer to engineering, because engineering is not independent as far as constituent of engineering are concerned. Raw material is concerned, natural material is concerned, resources are concerned, we are concerned, minds are concerned. We have to depend on nature for all materials. That's also a fact. There is no material that we can say it's mine, absolutely mine. No one can. Even those who handle materials, they can't say that. So when material comes from nature, body comes from nature, mind comes from nature, so what is mine? Therefore, engineering means natural involvement of materials, human resources, and of course technology, which comes only by not by some formula alone, but by experience. Already everything is established, every formula is established, procedure established. We have to just apply that in theory of structure, in designs, or in, you can say, other subjects like fluid mechanics, like surveying. Means we have to learn what is already available, and after that we are applying. We do not do any original work, and I don't know when original work might have started. No, there's no trace of that, no history of that. It's therefore very important. When we come back to quality, हम जब quality वापस आते हैं इतने कुछ बात करने के बाद, आखिर हमें आना ही पड़ेगा कि हम बात quality की कर रहे हैं, हम बात coordination की कर रहे हैं. और मैं समझता हूँ क्वालिटी और कोऑर्डिनेशन के बिना हम लाइफ भी नहीं चला सकते, छोड़िए इंजीनियरिंग की बात। तो क्वालिटी एंड कोऑर्डिनेशन, हिंदी में क्वालिटी गुणवत्ता कहते हैं, कोऑर्डिनेशन को समन्वय कह सकते हैं, या एक समय पे सही काम होना चाहिए जब भी हम डिसाइड करें। क्वालिटी एंड कोऑर्डिनेशन मीन्स दैट, एंड वी हैव टू सी वेदर वी गॉट इट और वी डोंट हैव दिस. That is what we say, revisit everything. We have to revisit every time. Revisit is a word, but we very ordinary word. We can say we have to visit and again visit. We have to visit same way, that's my is safe or not, it's working or not. Whatever we established should work or it's gone, disappeared. If it disappeared, we bring it. And that's where I can say quality and coordination are very temporary but very useful. If you condemn quality, you condemn coordination, you will not do anything, sure. Or if you do something that is off track, means not according to requirement. So our focus should be in design's work and work of execution. Both require quality and coordination. And when I say quality, it doesn't mean application of formula. It doesn't mean that alone. It means what we think about design. At time of design contemplation, we have to think. I'm not talking of details here. I'm talking of basics of designs. Means we should have a picture in mind what we are going to do. It may be, you can say, concept, or it may be a perspective, but that's actually not exact, detailed, but you can say some information must be there. And then design actually comes when you try to transform that information onto communicable system, onto communicable media, and that quality is important at that time. How do you design? How do you think? And we have to design in various stages, and there is a stage that we require input from all others. If I am a civil engineering designer, then I have to take input, I have to obtain input from all other engineers like mechanical, electrical, services, or plumbing, or you can say IT, or whatever else I think is important for that. Split is in various subjects, it can be. So at that time we can say yes, this is something, and that is a requirement. That's a, you can say, definition of procedures called coordination, and that coordination is affected only when we are successful. We are successful in communication to each other, and that communication we consider as a part of coordination, is a part of method. You can say it's a method that we involve in design, and design is therefore not so simple as the thing, not application of formula or codes, use of software. It's actually conceptual. Concept we should have, just like one engineer said, very senior engineer said to people, so engineers, that you have to talk to buildings, means you have to understand buildings, and that engineer is really veteran, and that engineer, Mr. Engineer Varyani, I was told that he talked to people in one conference long back, that you have to understand building, and this is really very important phrase. It has got very in-depth meaning. Understand building is not as easy as we think, though it's not done because it's not available. How can I understand? And that's where engineering plays. I can't understand that, but I have a picture in mind. I have it's it's a dream in mind that I have to do this. Can I do that? That's the point. Can I think about that? Means it's not software that will think. It's you have to think. How can you design it? How can you think about its operation in future, its response in future? It is the optimum response, or best response, or economical response. Means it is that stage of engineering experience what's there. And it's very great statement. In fact, you see, you have to talk to building, or you have to understand building. How shall building conduct? And no software can teach us that, or you can say no formula can teach us that. We have to understand ourselves. Yes, there are various formulas depend on various parameters considered engineering, but it's really very important. We have to understand ourselves. We have to talk in when I add to that statement, when you talk to building or structure, you understand that how it will shall conduct. And I have to keep myself also there. A structure is not alone, I am also there. How shall I talk to myself regarding that building which I am going to design? And that's my point. Is my concept should be first clear. Only then I talk to. So how do I conduct myself? self-imposition or self-investigation is very important. Just like we have to talk to ourselves, I have to talk to myself, how much do I know about this? Or how much more information I require about that? It's not simple just a track, or it's not convention, it's not convention. It's a kind of innovative idea you must have in. Means you must have something different that you can say. Your mind tells you what to do. Sometimes, it works better than all other schemes. Once you have clear picture in mind, then you can make it, you can improve it, and after maybe one or two improvement, you can say, yes, I have reached certain tentative act, tentative design. That's not actually actual design, it means it's called a dramatic design, and that shall be converted into real design. It's kind of qualities you can say we have to involve in design, not simply starting with some detailed work, or this is size of column, this is size of, no, it's not that. You must first have you can say, just like you can take example of very simple item that's called stool we use in homes. It may be wooden or some other material, and we have to sit on a stool. Can I sit or can I stand on that stool? Shall it be safe or it won't be safe? Or what sort of stool it should be? It means we have to think that way. Though it's very small item, it's not an engineering object, but it's a teaching object, just like a stool is stable. It doesn't collapse even if I kick it with my leg. It should not collapse. That's what I say I need. It should be safe. Engineering says it should be safe. Your structure should be safe. Your structure should serve its intended purpose, and it should not only serve, it should serve for long period to come. So all these 3 points, and it should be of course economy based, and economy doesn't mean money only, it means the use of material to optimum stresses. Whatever resistance metals can give in various forces to various forces like tension, compression, moment, shear force, etc., that should be used in an optimum way, so that buildings we design should be at least at lower cost, and material should be used in a better way for maximum allowable stresses or forces, and it should run for long. This means material should not loosen its long-term stress, and that's where engineering comes into play. I think detailed of designs, and you can say in details of designs, and once we get all this information, it's a very complex one, and then we can say we can change it, or we can amend it, or we can convert it to our designs, drawings, and that's where design works. And even then at that time we have to see, okay, this was part of design, this was part of concept, but here we have to make sure that this, whatever we are going to design, this should not be for us, this should not be for us or for my happiness or designer's happiness. This should be for happiness of that site person, who can comfortably, with good comfort, with ease of doing, can execute this one. That person should not suffer from any misinformation, because that person is not involved in design. That person understands design, but that person is going to do your work into a physical form, and actually that is objective of your design. To be very frank, your objective should be that, and we then can say it should be strong enough, it should be good enough that it can be constructed properly. And that's why we can say coordination play important role, and quality, because you have to achieve this construction should be good one, it should be easy one, not complicated one, so that my team, my associates understand very well what your designs tell, what instructions we get from designs, what instruction we get from contents of specification, or what procedure we can decide for that. Therefore, it's very say quality and coordination starts there. And it's not for my country, I'm saying it's for all, but particularly in this talk I am referring to our country. मैं अपने देश की बात कर रहा हूँ, क्योंकि यहाँ मैं देखा है, खैर और भी जगह देखूँगा, लेकिन ख़ास तौर से मैंने जो देखा है यहाँ पे इंजीनियरिंग में क्वालिटी बहुत गिरती जा रही है, क्योंकि सारी चीज़ें तो इंजीनियरिंग से आती हैं. कोई भी आप आइटम ले लीजिए, इंजीनियरिंग कहीं ना कहीं तो इन्वॉल्व होती है. हम इंजीनियरिंग को ही ब्लेम करेंगे, हम बाकी चीज़ों को ब्लेम नहीं करेंगे अगर क्वालिटी नहीं मिलती है तो. चाहे इलेक्ट्रॉनिक्स के आइटम हो, कोई और आइटम हो, सिविल की आइटम हो, मशीन हो, कोई बिजली का सामान हो या कुछ भी क्यों ना हो, और वो अगर नहीं चलता है, खरीदने के बाद काम नहीं ढंग से करता है, तो आप क्या कहेंगे? यही कहेंगे क्वालिटी नहीं है, उसमें गुणवत्ता नहीं है, सही बना नहीं, और क्या कहेंगे? वो कैसे बनाने, क्यों, ये काम तो हमारा नहीं, हम नहीं जानते उसको। इसलिए हमें समझना होगा कि खाली बातों से काम नहीं चलता है। इंजीनियरिंग का काम होता है करके देना, करना, सोचना। इंजीनियर का मतलब यही है, इसका नाम ही इंजीनियर इसलिए दिया गया है कि इसने काम करके देना है, बातों से नहीं, खबरों, खाली अनाउंसमेंट से नहीं, या खाली कविताएं गाने से नहीं, खाली पोइट्री से नहीं, चुटकुलों से नहीं, रियलिटीज़ से, वास्तविकता से। अगर कोई हमें वास्तविकता से बात कराता है, कोई रियलिटी से हमें इंटरव्यू कराता है, हमको देता है, तो वो इंजीनियरिंग है और कुछ नहीं है। और इंजीनियरिंग का मतलब होता है वर्क इन प्रैक्टिकल वर्ल्ड। वी हैव टू do something that should be used by everyone, or every one of that person or owner who invests on that. So we have to be very clear in our mind that what we talk is useful for everyone. Explanation should be elaborated, detailed, but should be reasonable one. So that's what हम कह सकते हैं, quality and coordinations. हम कह सकते हैं सो रहे हैं हमारे देश में, सो रहे हैं, सो रहे थे शायद, और अभी भी सो रहे हैं, क्योंकि हम लोग जागना ही नहीं चाहते। बहुत समझने के बाद, बहुत सोचने के बाद ये मैंने देखा कि हम लोग गंभीर नहीं हैं, सीरियस नहीं हैं। और जहाँ गंभीरता नहीं होती, वहाँ सीरियसनेस नहीं होती, वहाँ कंटिन्यूटी भी नहीं होती, वहाँ प्रॉब्लम्स का हल नहीं निकलता, समस्याएं वहीं की वहीं रह जाती हैं। और सीरियसनेस एक वो क्वालिटी है जहाँ से आप अपने आप को स्टार्ट कर सकते हैं, जहाँ से आप कह सकते हैं कि मेरा ये स्टार्ट बटन है या थोड़ा आगे जाके है, और मैं सीरियस इस मामले में। और दूसरे शब्द में आप कह सकते हैं, आई मीन इट इज़ माई बिजनेस, दो इट्स नॉट कमर्शियल बिजनेस, I have to remain busy on this point. This means that this is my point of consideration. I have to remain busy on this point until I get answer from this or response from this. This response may be running one or maybe intermediate or final one. It depends on what sort of problem is that. That's what I can say seriousness is. Seriousness doesn't mean something else, anything else. It doesn't mean that. I have to be in sequence with every problem. If I keep sequence, I keep history of that, then I can say, okay, I have to this extent applied this or amended this, but it still is not giving response. I have to try more on that. I have to try more on that, and that's what it is. Until I get some final solution, I can say this is a problem for me. Generally, we call in some way, oh, what's problem there? This problem there, but it's not a problem. It's something informed. Something is informed and something is not informed. Information is incomplete, or it's irrelevant information that I have for this, and that's only we can say. It's called a kind of coordination requirement. हमने इसको सही तरह से संचालित नहीं किया, समन्वय नहीं किया, इसलिए हमको प्रॉब्लम आ रही है। उस समस्या को हल करना पड़ेगा, और उस समस्या को हल करने के लिए इसको इंजीनियरिंग वर्ल्ड कह दीजिए, आप कोऑर्डिनेशन वर्ल्ड कह दीजिए। You have to set it right through coordination, through communication, application, and when you set it right, you can respond. It is engineering shall automatically prove it that it's okay. That's why I'm saying, हम सो रहे हैं और क्वालिटी सो रही है, हम सो रहे हैं और कोऑर्डिनेशन सो रही है। कोऑर्डिनेशन तभी होगी हम जब जागेंगे, और गुणवत्ता तभी मिलेगी अब हम आगे की कोशिश करेंगे, काम करने की कोशिश करेंगे, क्वालिटी उसमें देंगे। दैट्स व्हाई आई एम सेइंग, जाग जाओ, जाग जाओ सोती क्वालिटी, जाग जाओ सोते लोगों, जाग जाओ सोते अभियंताओं। आपके सोने से आपको रश तो मिल रहा है, लेकिन क्वालिटी नहीं मिल रही, और कोऑर्डिनेशन सही काम नहीं कर रही। इसलिए quality and coordination, get up yourself, get up quality and get up coordination. Stop sleeping in hours, be my friend, because I cannot work without you, to be very frank. And if I work without you, I work incorrectly. I cannot assure myself what work I do. and therefore it's very important point that we have to understand. In words of quality, that point is always very important, and we cannot take it for granted. We have to think of that. You cannot leave me because you are my destiny. And when I say destiny, it's my thinking destiny, it's my work destiny, it's my attempt destiny, and it's for whole nation, it's for all others. And because engineers can handle you successfully, engineers have to be aware of that. They have to keep it all time with them. That is very important. And that's why I say quality and coordination are required to be established in engineering professions and also all other walks of life. And there's nothing new I'm telling, it's everywhere known like that. Quality is to be applied properly, and that is very important point. And therefore I can say I go to file here, that file is you can say this was quality file. I'm going to here coordination engineering, which I have started recently to just have elaboration, just have to discuss about coordination, and we call in our language Hindi, this is समन्वय, I think that is right word, समन्वय, और एक दूसरे के साथ मिल के चलना, अपनी प्रॉब्लम उसको बताना और उसकी प्रॉब्लम को सॉल्व करना, जिसको हमें आगे लेके जाना है. और ये सब जगह होता है कोऑर्डिनेशन. दिस आई एम टॉकिंग ऑफ इंजीनियरिंग, बट आई एम टॉकिंग ऑफ कोऑर्डिनेशन इन जनरल एज वेल. Coordination is a part of life. It may be formal part or informal part. Without this part, we cannot say anything is done or can be done. So we have to be very practical as far as coordination engineering is concerned. In this I can say coordination engineering, projects and engineers, and we are talking about that, which is very important one. And we say for reliable quality engineering works, delivery is a professional note it is. It's a document that I recently prepared for just to keep myself also different in this position. I also know that what I have talked so far, it's not simple some entertainment, but we have to be serious about the engineers and projects. And when I say for reliable quality engineering works deliveries, we can say we have to be little smart. For reliable quality engineering works, and we can say, हम कह सकते हैं कि reliable quality engineering का क्या मतलब होता है. जो भी आप काम कर रहे हैं, पहली बात तो वो क्वालिटी से होना चाहिए, और क्वालिटी से वो कब होगा, कब क्वालिटी से कहेंगे हो गया, हम कैसे कह सकते हैं कि इन भाषा में, आम भाषा में, मैं प्रोफेशनल भाषा की बात नहीं कर रहा, इन एन ऑर्डिनरी वे, इन एन ऑर्डिनरी लैंग्वेज, सो दैट एवरीबडी कैन अंडरस्टैंड दैट. वी कैन से दिस वर्क शुड बी सेफ. ये वर्क साफ होना चाहिए, सही होना चाहिए, सुरक्षित होना चाहिए, और ये सुरक्षित ही यूज़ होना चाहिए. जब भी इसका प्रयोग करें, इसको यूज़ करें, तो उसमें कोई गलत चीज़ नहीं होनी चाहिए. वो अच्छा लगना चाहिए, यूज़ करने के लिए शांति से रहना चाहिए, और उसकी जो उम्र है उस काम की जो हम कर रहे हैं, उसकी उतनी लंबी तो होनी चाहिए जितना सोचा गया है. ज़्यादा भी हो सकती है और भी चल सकता है, क्योंकि हमने इसको मेहनत से बनाया है, तो उसको ख़राब तो नहीं कर सकते. That's what I'm saying. Reliability is very important part here, and reliability means one work should be safe in all respects, and it should serve safe, and it should serve for a long period. Let us say it can serve for 30 years, 40 years, 50 years, 100 years, 200 years. That depends on, and accordingly we can say design is impacted upon. We have to do right design and not that that's impacted upon. Now we can say for our support and reliable coordination, we have to do a lot of procedures we have to understand. Now I'm giving some examples only just for your reference, that you can see this photo. This is from I've taken this from Google, and because at that time when this was done, I was there. I did a lot of work on this. I was project agent of this project. It's because this building is school building, a group of buildings, it's a school building, and it's located in Qatar actually, and this was constructed in 1986 to in 1986 I took over site from government. This site, of course, I worked that time in Alatia Contracting, which is in brief called LCAT, and this project is located on Al Khor Road. You can say if you start from Grafa roundabout in Doha, graph around. At that time, we used to call it graph roundabout, and used to go long way to Dukhan. That time, I mean, on way, if you start from Grafa to Amsalal, it's just approximately 8 kilometers from Grafa roundabout. You can say you reach this site. This is at that time there was nothing much on road, but now there's a lot of development happen. Well, I'm just giving location of that. Amsalal Qatar Boys Preparatory School. We did it at that time. At that time, our contract price was 14 million reals for this project. Big amount that time, but not very big. Yet, I'm not concerned with amount as far as I'm talking to you. It was about RCC structure. It was about quality. It was about how it was done. I'm just informing that this project, moreover, Qatar is a rocky area, you can say. Generally, in Qatar, you'll find in excavations rocks, and not very hard rocks. Somewhere it's very hard, somewhere it's not hard, it's soft. Somewhere it's limestone, somewhere it's not. Somewhere it's a fish shot. So excavation was done actually using excavators with replacement of bucket by hammer, you can say hammer, and excavation of course took time. So I'm just trying in our experience. I like to share certain projects with you for purpose of clarification and what sort of coordination we did there, and that's very important one. So this project is a school one, you can say, and it's not, of course, not very complicated one, but RCC structure it was, and keeping in details of that structural arrangements, I could, at that time in 1987 or 86, I remember 86, I could say that this was designed on working stress method. Well, it doesn't also, but if you can see in this case, I like to say, well, how does it happen, how does it work, you can say. As pinpoint, I'm pointing towards my mouse that this is a school building, you can say, and this is a road, of course, you can see these cars running here, and of course that's also so, but other road is outside, this main road, this service roads like that, but here you see is a boundary wall, and here you can see this one building is here, one building is here, and one building is here. Of course, these are all buildings of different types, and this is another building here. All groups of buildings in this, and this is another building here, is called mosque for this. And this is not a building, this is a cover, is open. I mean, this is open at that time, I was there, but later on they covered it maybe by some light section of polycarbonate or whatever. This is entry to school. And this was assembly hall area, and this is support to assembly hall area, and this is workshop area, you can say, workshop class, and classrooms area here, likewise classrooms area here. And this is laboratory areas and other areas, likewise you can say. This is ground floor, the assembly hall is double height, you may say here. It's not single height, and this workshop is single height. And all these rooms are 2 stories, here is 2.5 story here, 3 stories here. This is double story, and this double story. And mosque is also double height as usual it used to be. And this is skylight system of mosque. So this is very, very normal, but I'm just trying to explain what did you do. And this project was, at that time I was too young, you can say. It was 1986. And I was maybe not more than 30 years. I was a young guy, and I came from, before this project I did, I was given 5 more schools, existing schools. Existing schools means those schools were built, structures were built, buildings were built, landscape was not done. And these 5 schools were located in Doha city itself. So I did landscaping work of those. There's hard landscape, soft landscape for all those 5 schools. So you can say I started in Doha with landscaping of existing schools. It's called schools program landscaping. And I came from Libya to this site, to this country. And in Libya also I did some projects that I'll show you later on. I don't have the records of that now. I'll try to get it from Google if I can get. And also then before Libya I was in Iraq. I have some projects of Iraq which I handled, and that is, I can say, here. That's one building. It is Daral Thawra project here. It is that building here, I can say. And this building. I'll discuss about this also in this talk later on. This building, this is that building, and it's that we worked on this. It is adjacent to that, it's adjacent to the others. This is a palace, conference palace, so we handle this. RCC tower, it was constructed, and also this one more, this is Iraq, and then because I also did this another project that's taken down to Google itself, and this is a plant which is very big one, and it is not refinery exactly, it is ethylene plant also in Ruwais, Abu Dhabi, and this is another project I'll discuss with you. This is about firing range or shooting range, you can call it. It's about too long, 330 meters long here, and this is also very specific project, and I did this in 1987, and also this another these are all something these are only few I've taken from experience. I'll add more to this, but I want to explain, I want to confirm practical aspects rather than just speaking for nothing, because engineering is demonstration. I'm trying to let you know where I'm talking about when I say coordination. I'm talking means we must have done coordination. Only I can talk in that. Otherwise, if I don't do that, there's no meaning of talking, because I do not do that work. So what I say on this project, when I start with this one, because it should be clear one first of all, that is RCC structure, and it is not deep footings but ordinary footings. Of course, there were about 300 columns, so you can say. I just remember that exactly, as if I don't know, but 300 structural columns on these buildings, and you can say 300 columns are not small quantity. You can say in this itself there are about 1, 2, 3, 4, 5 or 6 buildings grouped together with one building of mosques. So these number columns or 300 columns are practically possible in this case. We can say yes, we can have this. We cannot go against that. We can have so many here, and that's you can say yes. We can accept that point. This 300 is not very big figure for this, and it can be accepted. Let me put on some switch. And just the battery question, I want to control my battery, that's why I put off switch, because administrator told me it's better that you keep your switch down all the time until it's not required, just to increase life of battery, and that's what I'm trying to do. Well, it's only for information. Now I'm just going back to this, and now I'm talking about this school. You can say building 1, building 2, building 3, building 4, building 5, building 6, building 7, you can say. And there's one small building here that's called God House or whatever you call it. And then extra this boundary walls, and there are other areas with many more requirements, and we can start. Now what I say, though I said 300 columns were there, and there were of course expansion joints with each building. We cannot construct all this integral. There was assembly building, as I said, this one assembly building. I like to go back again, this assembly building, and it's exercise. So this is complete one building here. There was separation here, and that is, you can say, expansion joint. There's another building here, right, and there's a workshop. So there's another here expansion joint, and then there's a group of buildings here, and likewise there's a gap here. This is another building. There's a gap here also, as I said, there's a gap here. It's not visible here, but there was a gap. It's a gap here. Of course it's covered one, but there's a gap. And same way here, and this entry, this central portion where generally students gather together in morning time, and also this is mass isolated one, and our offices, temporary offices, somewhere here just adjacent to mouse. There was a tower crane we used to fix. I'm just trying to say what we did, fire information, how works are done. This is very preliminary I'm talking, but and here was nothing, just we had a access here, service access, and our nameplate was fixed on road itself. So somewhere here was fixed, and then there was nothing on this side here, just a desert completely. It was a desert, and we had to think of how to do this job. I was too young, didn't have much experience, but to learn. and I tried my best to involve myself. I had there, one above me was head office engineer. I still remember his name was alias Francis. I was there as a site agent or project agent. We had our office in Doha, Qatar, central city, and I used to go there every day and come in morning and have. I had about two engineers with me. One was both Lebanese, and we have to work with international people. We have many workers from Thailand and many workers from our country, Bharat, India, many workers from Pakistan, and many workers from many other countries. British consultants, Qatar, this was Qatar Consultants Group, you can say, QC Qatar Consultant Group, and I had to deal with them. The department was Civil Engineering Division of government of that country, and it was, you can say, civil department. Of course, was not army work; it was ordinary work. But I'm just trying to refer this because this was a contract, package contract. Package contract, this is lump sum fixed price contract, not item based, and price was fixed, work was fixed. So you can say it's lump sum contract, and that's why I tried to learn a lot on lump sum contract during my experience. And the quality was very important, though in those days there was no quality system in existence. But we have to depend on Qatari. We at that time used to call it QNBS, Qatar National Building Specifications, and British codes or American codes in parallel, as well as practice, you can say. At that time, ready-mix concrete was very powerful in those days. Of course, with certain deficiencies, you can say, not using, you can say, micro-silica. Now we use GGBS. Likewise, at that time, this was not in fashion. So I'm just trying to tell what was the state at that time. And I still remember everything. I didn't forget, because it was my Gulf project, not Libya or Iraq project or India project, Gulf project. And it was like, a learning stage for me, where I had many teachers, I mean to say, interactive people like consultants, government people, our own company people, and various other agencies, as I did same with when I was in Libya. I will explain to that also, about that also. And I was in Iraq before that. I have that project also. I'll tell you, I'm just concentrating on this project. My first appeal to you is that I want to express to you what I did, so that you know what I'm talking about. It's all based on practical experience. It's based on, experience that we had to do. Maybe I made many mistakes there. I can't say I did everything right. Mistakes in a sense that when you have to do, you don't know everything. And you can say in those days, if you remember now, I'm talking of 86. This project might have started design in maybe 82, 83 or 84. So this is a design of 84, you can say. 84, and now it is 22. 84, 16 plus 38 years back I'm talking. What was engineering at that time? What was state of construction at that time? What was speed of construction? What was quality involved? What was quality involved? When there were no computers. No computers on sites, no computers everywhere. I remember we had only one system in our or two systems in our office, big office of course. We had three divisions in that office. One division was buildings, one was roads, and one was infrastructure. Those three divisions in either our organization. I was a part of building division, which used to have contracts from government or other sectors, and all buildings contracts. And first contract that I handled, I was not a manager there, I was a very ordinary person, project engineer, you may call it site engineer or site agent. So as I said, I started a landscape project, and I never did that before in my life. And I also learned from there, because we had to deal with external and internal landscape. And that is different kind of, not structural one. And for an engineer it's difficult, because engineers understand, I was having good strength in structures that time. I had good knowledge of structural designs. I started actually with structural designs, and with manual working and not with computer working. Manual working and calculating everything, first principles, working stress methods, and especially in RCC. I started at that time with the complete I was actually involved in engineering work. I just let you know what is engineering and what is designs actually. Engineering means a kind of coordination work. Engineering means a kind of dealer, you can say, in all. You have to deal with designs, you have to deal with quantities, you have to deal with construction, you have to deal with planning, you have to deal with whatever else is required. In quality, of course, quality. So you can say it's a kind of body. You may say coordination engineering is a body of project working, project organization, or you can say now we can call it, I don't like this term, but it's like the use of management, organization, that we can say. So coordination is that. It's not simply, as I said, you talk to others or deal with others. It's not that. You have to solve problems, and that is coordination. In other terms, we call it on modern projects engineering division. Engineering division involves designs, involves planning, involves quality input, and your problem solution. Solutions, if you can't find, you can't do project. That is first requirement. And this solution is not design solution or original solution. This is just something we have to add to existing one. We have to make sure that we can do this job on field, in field, on site. That is what is coordination. We should not delay, we should get quality, and we should keep cost. So there are other professionals for all those subjects independently, but coordination is that, you can say, kind of distribution board that keeps safe and tries to solve problems of every supply line. So we can say coordination means to start with design coordination, to make sure that design is implementable, it can work. It can work, and on site we have no opportunity, we cannot afford to waste time. That's another point. We cannot waste any time on site. That is not acceptable. And if it is because of coordination, then it's very difficult to understand this point. Why coordination is done at same time and why not before this work is started? So that's what I'm trying to say. When we plan something, coordination is an important part of that. We have to start coordination at design stage itself. Coordination of all drawings, all details, even dimensions, sizes, everything. Sometimes what happened, because in those days with the computers, the self-checking, architectural drawings are there, available, structures are there. You find that both dimensions don't meet. In total, it doesn't meet. It should be. Likewise, we had to check everything, but it should experience, you can do that. If you don't have experience, I can say, oh, I am a structural engineer, don't care for architecture. Just like I used to think in beginning also. In beginning, somebody told me, oh, your structural drawing is important, don't worry about architecture drawing. You are given this time, you follow this. That was initial tendency. You can say tendency because you are a structural engineer. Either time I was a structural engineer, I was a designer, I came out of university and experience on structures, executions and designs, and of course I was not master of anything, but application of design, or you can say implementation of design itself on site, is very big thing for a young boy, for a young engineer. And you have to, particularly in Gulf, you have to work independently. That's another point. In our country, there are so many channels. You can say, oh, this is chief engineer, this is superintendent engineer. It's like that, so many. Forget that. That doesn't work. When you share responsibility with the one and nobody does anything. So in Gulf, it's a different scenario. Maybe many of you do not know that. Engineer means you have to handle project independently. Otherwise, you are not engineer. You cannot be called engineer. You may be called foreman, you may be called supervisor, you may be called whatever you say, surveyor. Even survey is independent these days. You cannot call surveyor also. So in Gulf, this term is very responsible. And maybe here also now, I am not experienced here. What is engineer means? In Gulf, in Middle East, there's clear-cut conception. You have to work It is you who are responsible for this project. So well, I just gone to some other, but when I'm talking about this project one, project school, talking about, we had 300 columns in this, and we have to start with, and I just, for your information, this assembly hall where we enter this building, it was having one part of this. There are three parts in that. Just I let Agri post it on this again. In this part, you can see this assembly hall. This span of this one, this span, it was 18 meters here. This is about 5 meters here, and this also here 18 meters, and it's less than. So main was 18 meters, 18 meters span, and here and periphery they are fascia. Here they are fascia work, fascia RCC. So a little complicated, but 18 meters span is not a small one in RCC building. But it was done, and I like that. Beautiful design based on working stress method. Working stress is a method, means first method in engineering designs, where it's not like a limited state, it's different. That's not part of this talk. And we did that, and I still remember in this area here, particularly on this when I'm putting my cursor here, I faced a quality problem in this. Really, I was ashamed of that. Ashamed in a sense that this beam, you can say, of course there was a beam and there's a fascia, and there was some bulging at about height of 4 meters. Bulging, what does that mean? It's a very common word in construction. Though this is not used as bulging, it's used as opening, or you can say a shuttering opens to some millimeter, and concrete profile, concrete surface doesn't remain in vertical, is plumb. You say it's bulging, means concrete coming out of line in a curved position, and this was checked by some supervisor of consultant, and it was a big problem for me, in fact, because this was fascia. And what to do then, I could not understand. Of course, when something does like this, your shuttering comes out, it still remains there, it doesn't come out. That's also to understand, means it's very important. If it still also comes out, it's a failure, you can say, in that case. But it was investigated, and I was putting questions, how it happened, who is responsible for this. Then I simply said to my management that this is my responsibility. If you want to take action, you take action against me. No one else is responsible. It's my responsibility. Many times that my senior asked me, I still said again and again, I am responsible. We shall do it, correct it, because consultant instructed to chip it, to scabble it, and wants to see, they make sure that steel is intact, and steel was intact. So no problem, I'm just trying to refer to you how it happened. It happens like that. You can't say, it's beyond your control sometimes, and sometimes it's low quality work in preparatory works or shutterings, that supports are not fixed properly. We cannot be sure of that, and it works as such, and we have to be very serious about that issue, and that's what I say we have to be. It's not easy all time, means we have to be little clear about this. We have to be little clear about that fact, how we did. And then this was an issue, and we solved it. And also it happened there once that before this, I did not tell you what happened. When we were starting this project, concrete was to be done in foundations, and I was there as you can say as a supervisor, you also say, though I was the engineer, but I have to supervise us along with others, because if you don't supervise yourself, you can't depend on others all the time. Particularly in the start of project, when you start some project, you have to be very careful from very point, because your consultants are new, and you have to prove your efficiency, and consultant wants to prove their efficiency, how much they can examine, they can check. So it is a part of job, it was a part of job that time as well, that when trucks of concrete come from ready mix batching plant, you have to check your you can say temperature, you have to take slump also. And it was practice, but I thought if I don't take one truck slump, no problem. Once I have taken for many trucks, in this truck also, I assumed it should be okay. And it's my bad luck, so bad luck that time that head of that consultants, I remember still, Nigel Robinson, chartered engineer Nigel Robinson. By chance that truck came, and I allowed that truck without taking a slump, because I okay. And that person noticed this. He stopped that truck, called me. I want to check slump of this. Why didn't check that? Oh my God! I was I had no answer because this happens. So unfortunate, you can see, and that truck failed in slump. I had no explanation towards that. So what effect that brought to me, that my curriculum vitae for that project had been pending approval, and that person, that chartered engineer of consultant, he held my approval, because in Gulf, in Qatar, at that time I'm talking, there was a regulation that you were allowed to work on a project if you belong to a contractor only if your CV is approved, and until CV is approved you are allowed to work provisionally. I mean, if it's not approved you can't allow to work, you can't. Well, that person did not like me at that time, and he had a bad image for me, that this person cannot even check slump. Temperature was okay because the weather was good. It was not that bad, so temperature was below 32 degrees Celsius. It was early start of that time, maybe month of you can say March or April, May, April. Well, means it was okay. Early morning this truck came, and if it was 2 o'clock or 1 o'clock, then it should be different. So what happened? And I was trying to tell. Then I say it happened. So I was very serious at that time. And this happened for this building. We did it successfully, nothing went wrong in this. And I was also, we were very efficient in pouring actually, I tell you. Means there was 300 column and we started pouring foundations. And then I think 5 or 6 attempts we poured all foundations. We had good planning there ourselves, we planned, and our senior, this Lebanese guy, as I said, Engineer Ellis Francis, he was smart enough in pushing, and he of course he did not deliver materials too efficiently, but we planned. I had 2 engineers with me, and one Palestine engineer, or you can general foreman was there, Mr. Jackie, and one was Engineer Khalid and Engineer Nicola, and of course we had a good team of engineers, and Thailand foreman, our foreman, Pakistan foreman. And I trained after that incident of slump one Pakistani person. He was interested to learn all this, though he was it's a helper class, but he tried to learn how slump is taken, how slump is tested, how temperature is tested, how weather temperature is taken. So I deployed that. I think his name was Lal Muhammad. I still remember. It's 1987. And that person was good in work. I installed him for this purpose. You have to give me daily information about this, weather temperature, concrete slump, whatever it is, and whatever is related to that. And you can say it was about 6,000 cubic meter concrete, 3,000 or 4,000 cubic meter structural concrete and others concrete. So you say, you can say if one truck brings for 8 cubic meter, you can see you need 250 cubic meter for 200, 250 trucks for 200 cubic meter. 200 trucks for 1600 cubic meter. 200 is 1600 cubic meters, so it was 3000 double than that. So many trucks had to come. And of course, sometimes it was frequent supplies, sometimes it was supplies for columns. So it takes, frequency differs, and we use pumps everywhere or tower crane. And there was and one building here, we had to cast this slab. You see this one. This was a slab we had to cast, and our tower crane was here. I am sure this was that. Well, was that. We had to pour this slab. Yeah. Then we had one side diary in those days according to contract provisions. We had to record every day's information on the side diary. Nowadays they call it works job record, or you can say job record, or daily job record they call it. At that time side diary was very important document. It was a kind of reference document. Every day we had to submit report of side diary. Means on side diary you can say there are so many columns in that. Generally whatever happens on that, you can say today's activity, this is we have done, this is a planned activity, this is already done, and this is what we shall do, and likewise how many workers are available, or whatever transact on site, or you can say what material comes, what material goes, which machine comes, which goes, who are visitors. General information of site regarding works was entered there. This was bifurcated page vertically, one column, another column. On one side we had to enter information, on other side consultant had to use writing. There was no other format. This was main format for daily job records, for side diary it was called, and every day we had to submit this to consultants and to our company regularly. And whatever happened on site, that must have been reported here. Even inspections were recorded on that, inspections. And it was really interesting that we had to do everything manually. And if it is approval or rejection of your inspections, that was recorded on that diary itself. It was really interesting one. And that's why I'm referring it to, because there's some meaning behind that, there's some requirement behind that, what I'm trying to say, that we have a requirement. And there was one question one time, although I never thought that this would be required, and just I'm trying to say how it happened here. If you see, this bore was not a problem, because this span we had crane, we had pump we could install here, and nothing was done on this side at all. So this is enough, you can say. Pouring was not a problem for this portion, and we had enough space here as well, space this side. So this slab pouring was not a big issue, because this was poured at one level at 4 meters, then other level at 8 meters. So we poured in two levels. This is a double height hall. We did not find any major problem here also, because we could pour from this side. It could cover entire area, same way it could cover entire area this side as well. And also means there was nothing here, so we could bring our you can say machines here and pour here. Problem was that because we did not have, here was a building, there was this area. Then in this area, some problem for first slab, and there was a question how to do it, because not what was clear in those days. I was asked a question, how shall you do this? Give method statement. Sign this, and there's no form for method statement, no typing work, no computer, not. So, well, first I could not understand what do they mean by that, but later on they say you have to give method statement for this, otherwise we will not approve this pour. Actually, I was not on site, I was in office, and this engineer on site, he was concerned asking for method statement. So as I do, okay, no problem, why you worry? I also did not know what problem is there, I also didn't know. Okay, don't worry. And I thought what to do means that person is not going to approve this, I can't do this job. So I thought a little just for 1 hour what to do, how to do. My method, of course, he wants method how to pour with. What's the problem with that? The way we are going to pour, we will write in that. So he made a note in the diary, method statement is required. And that person has authority to do that. Okay, fine. No issue, we'll do that, I said. So next day what I did, I made a sketch of this portion, and I oriented this on, and there was one tower crane here, Then we had mobile pump. So we asked that we will get two mobile pumps. And I tried on sketch that this tower crane could come to certain area. That pump also could come to two locations. And it was enough that this portion was not ready at that time. Of course, foundation was, but the access for pump. And here also pump could come. So we tried to, for big pump, we used 2 or 3 locations for this bore, and tower crane, of course, some corners. So I just mentioned that on a sketch, how we are going to do this. And that clerk of work or that consultant's engineer, you can say, that person was, you can say, practically convinced that by complying with this statement, we can try and this can be done. Though this was not big deal, but because I didn't know all that at that time, what is method statement, I just conceived in my mind what to do and to do. And I transformed that sketch into that diary, and that engineer signed that, okay, subject to success, we approve this. And that was sent to head office of that consultant. This means we had to work that way. Then we tried with ready mix plant that we are going to do this, you provide pump accordingly. And we want supply like this, in this frequency. And our engineer that associated with me and our head office engineer, actually it was my examination, not their examination. If I failed, means company failed. But I was sure, because this is what we had to do, otherwise also we would do same. Even if this method statement was not required, we had to solve this problem ourselves. And this is the only way. So the plain sketches and ballpoint pen. And we did that way. And that particular consultant's engineer was available full time to make sure whether I just joked it or it's a fact. And you see, good time that we completed it successfully before time. At that time I tried to understand what this means. What is meaning of method statements? So that person, that consultant knew about it. What is method statement? But I did not know, because no one demanded that. No one demanded that. And really I said, oh, there is some document, there is some procedure that method statement is required. And it helped me a lot in my future careers, that I could do something on that, you may say. There was a time in my career when people used to value me as if I was a technical engineer. It's a different terminology. I could not understand what's technical engineer. Oh, he's technical. Means there are two terms, engineer and technical engineer. Just like design engineer. Oh, yes, he knows technology of engineering, and we know only work of engineering. It was a little, people generate their own definitions. And one side I was an office engineer, one Syrian engineer, or I don't know, Lebanese engineer, he started calling me engineer officer, not officer engineer, officer engineer. It just happens on sites. Language, English is everybody does not know, and I don't care for English language everywhere, because I know Arabic engineers, they speak little different than we think it should be, but meaning should be clear. So language is not a problem. Technical work and methods are a problem. If we can't constrain, we should not laugh on that also, because it's not their weakness, it's our weakness. Because we have taken English to that level, they can never dream of. So it doesn't matter that my head office people, I was involved with all, these Arabic engineers and British engineers and other countries' engineers. So there was no engineer from India except myself. And therefore I tried to learn a lot from them as well also. Means they could tell me in their own way what they speak, how they write. Though that's not a part of this, but it's a part of coordination that we should understand what's their background, how do they work, and that's also important. So I'm just trying to say that that you can say here, I think, is that this project had about 300 columns, many in this area, many combined footings, and you can say we did not go one by one, but we excavated whole lot, you can say here, excavated whole lot, because if we had excavated one by one, we could not do anything. We excavated whole lot, and excavation depth was also not too deep, because levels were almost it was eroded ground, you can say. It was not profile, and foundations were not more than 1.5 meter, and it was substation here as well, you can see. So it was not deep foundation, and it did not take much time, except because it was a rock, lime rock, and it took time for excavation because of that reason. Otherwise there was no other problem in that for excavation. And we kept site tidy for purpose of foundations, and that was very interesting. I don't accept if work is done in uneven area, because that causes safety problems, and that causes access. And so when we have all area excavated, we could easily take our machines, take our concrete pump, or whatever we have, to foundation level, to formation level, where it's not done. And our person, this was General Foreman, Palestine Foreman, Mr. Jackie. He was excellent in handling workers. He was excellent in demanding from me details, what to do. He used to come to me again and again. Okay, give me this detail, give me that detail, tell me more what to do. Well, believe me, despite having age, he was very smart. Of course, he was not good in writing work. He knew English. He was a Canadian citizen, and he did good work as far as workers handling is concerned, as far as details collection from engineers. And he used to come to me. Very rarely he used to go to other engineer, because he knew that I had all details ready, or I was busy in drawings. That's why I'm saying coordination is very important, because everybody cannot coordinate. Of course, I cannot say cannot coordinate. Other engineers could coordinate, but not with that speed as it should be. And when you have to plan every day, I used to take all team with me approximately every day one time, maybe in the afternoon, because it was all were there. Our office was here it was, and it's just moving here and there. So just what's going to happen tomorrow, you have to do this. And I also used to go to my office in evening time, just to have instruction from them about materials, or place materials order, or just to know what they want to say or what's going to happen. So I'm just trying to say, technical coordination, though it was not very big project, it was not very big, but considerably big, keeping that time stage when the economy was down, projects were down, and I had to deal with this project. And I am happy that in that time I could handle this concrete work, structural work, in about I think 1.25 year, 1.5 year. And I liked it. There was another problem also on this, in same area, you can say, I think somewhere here or here it was, that I exactly don't remember. We had a problem during concreting slab. I have a point. We had a problem, I think this is slab it was, yes, first level slab. There is no first level in this. There was a problem in this concrete pouring, that during pouring, I think we had a breakdown of supply of concrete, and there was no major parallel arrangements even in batching plant, though we got supply from batching plant, and we had no standard arrangements on site. We had no, you can say, calibrated mixer at site or site batching plant. So we had to stop concrete for very small portion. We had to stop concrete and immediately construct one stopper for that purpose. And the consultant accepted that, there was no issue on that. But what I did not know procedure. I say, okay, we'll do next time. And this consultant did not object. And they came again next day. I say, okay, we do this and finish this. What's the problem? And we did it. He was not there. He came again. What's going on? I think his name was, whatever his name, well, what's up? What's you doing? I said, we are completing this remaining. Who asked you to do this? Did I ask you? Did you get my approval? Approval is required, so already approved. No, you don't know regulation. You don't know what specification. You can't do this. Oh my God, yes, you can't do this. He did not accept. He didn't accept. I had to stop it. Then he showed me specification. He showed me specification. See what's written here? You can't read a specification. You have to wait for 24 hours minimum. You have to wait for 20. That time it was 24 hours minimum, though it can be more. But I'm just trying to tell that because at that time there was no low heat, something like that. So a 24 hours gap is required according to specifications. You did not read that. And you have to prepare this joint correctly, and then only you can do. Of course, we prepare that joint, we put slurry and again. No. So we have to do it again. I'm not whole slab that portion. So that was a point of learning. Means you have to be ready with all the specifications and all regulations or conditions of contract. Only then you have to move. So this project taught me something practically. And I learned another, I think these were 2 points I had seen problem here. And there's another problem of backfill that I did not discuss with you in this project. These people, when you work with contracting companies, engineers are very careless sometimes. They think specifications do not mean anything. And my senior was not happy with me, if to be very frank, as far as specifications are concerned. My head of department, Engineer Elias Francis, used to call me, oh, you are not doing for company, you are not working for company, you are a consultant. I don't know how many times he told me this or to others, oh, this engineer is consultant. But he had no option. I had to be there because it was a requirement on contract. There must be a qualified engineer. And otherwise, you can't run site. I was at that time, I can say, member of Institution of Engineers. At that time, I was a chartered engineer. Though it was not known to me that I was chartered engineer, but I had no certificate. I had a membership diploma. Postgraduate diploma. Membership diploma is called. And they knew that I'm a qualified person, though my CV was not approved. Yet I had to do this. Well, anyway, so what happened? These Lebanese people, they were very smart. They wanted to prove the pushing job. They usually call push job. In Arabic world, usually this term is used. Push it. They don't say we want to go. Oh, push it. And my Lebanese also. Oh, you push it. Push it. They usually say this, push it. Well, we knew what he mean by that. But he always said, you are an engineer. If you're doing this much material, you have to think for profit of our company. You think profit of this company. He always used to say me this. But you see, you have to do job also. I used to tell him, can I do this? You'll accept. Got my point? Well, that was different dealing. Everybody wants. They don't care for. So backfill was done in full. You see, you had to do more than 1 meter backfill. And who thinks of layers and courses? Though we don't do everywhere, in one place they did it. I think it was this place somewhere here. Backfilled once by shovel. Each machine is called shovel. They just backfilled it, and there was no test conducted or this question was raised in contract meetings, when you conduct progress meetings, you can say every month. The quality is also a part of that. In beginning it was very fine, but at one stage when when this was, it was question of backfill. This question was, it was raised by our consulting engineer, site consulting engineer, that they have done backfill without players. And it was a big issue. I was responsible for that because I did not take care. And they were joking, okay, you get Traxler machine here, if you can get Traxler machine, we help you, no problem. I couldn't understand what is Traxler machine. Traxler machine, on railway tracks, you have gravel, you have backfill, sand, you have to improve it. It's a machine that is Traxler, that moves on track, and there is some jacks, vertical jacks, which goes into that and they compact it. So it's not possible, you can't say that. I mean, we had to do that portion. The flooring was not done. Flooring was not done, only you can say, even blinding was not done. So we had to take out layers and do it again. So I was infant engineer there, I did not know what was the responsibility, and that's why I can say I'm particularly saying those projects, I learned a lot, and this was one of that. It's really, and here is the mosque, in mosque, we did not have any drawing. We had a drawing, I mean, we did not have final drawing, there was no angle set for this. You can see this is, you see this is building, it's a different angle. Or you can say this building is always a different angle. So we said, where is the layout of this? Give us layout. We raised a question to consultant, query to consultant. The consultant said, it's your job. Why are you asking us? I was surprised to know. How my job? You have to give drawing. Oh yes, we have to give drawing, and we have given drawing. You go to area imam, and ask that imam to come and show you what angle you should fix this. Oh, I was surprised at that. I didn't know this procedure. You should know procedure. What's procedure in this country? It's not our duty to tell you what angle it is. We are given design and has to do it. So we called imam. Imam came. He fixed a point on this line and this corner. You can start your building. And this was made an entry on our site book that imam gave this orientation. So why I say that sometimes you have to learn a lot on project itself. And here also, what else we learned, there are so many issues we learned. And before that, you can say, of this job, there was no major problems other than these I explained to you. Of course, extension of time, building, and that's just different. I'm not going to discuss about that. When I say about, you can say, I'm just trying to tell you something else, though it's not a part of this, just a reference one. And that is, when I was working on schools landscape in Doha. There were 5 schools, and we had to do sports surfacing. Sports surfacing, or you can say something that's very different. I never did that. Sports surfacing, maybe you people know now, but in those days, it was available. Material came from France, and we have many layers of that. It was to be done on bitmac. You can say bitumen paving. It was to be done, and we had to do that. But what to do, how to do, we didn't know. But there was a provision in contract that company that manufacturers would send representative engineer for purpose of demonstration of application of this material, because this was specialist material. So engineer came from France to demonstrate that, and it was volleyball court, tennis ball court, it was handball, football pitch. I mean, what to say, volleyball, tennis. We had to do surfacing on that. I didn't know what is that material, how it is done. So we were given demonstration by that French engineer. I had to be there to learn also. My team was there. You selected few people from our team to do that job. And really, I can say we learned a lot in that high standing sports surfacing system. on bitumen. There were many layers in that, many coats, and then final was lining. And still I remember I even used that procedure on my writing, on my authorship book, Building Practice Civil Engineering, which I handed over. It was published in 1996. Still I remember that time. We learned a lot every day. We used to go and learn, I think, of the week. We learned that and we got one team ready for that. So that was another learning in our project. And you can say that that's why I'm stressing on coordination, that coordination is very important. We have to be very serious about that. We cannot just jump on everything and say we know it or don't know it. And that's why I started this coordination work. I have many more examples to share with you about such experience. We had learned about epoxy flooring also on one project in Doha. We have to learn about epoxy flooring, how epoxy flooring, or you can say epoxy painting on floor, epoxy coating, 1.5 millimeter, 3 millimeter, etc. are done. And I also learned in there itself, which will take up matter later on. I've taken a lot of time on this project demonstration of one building. I would simply say that it was a good concrete work at that time, and we used to cast full height, and that's our beauty. In Iraq also we used to cast full height. I did not learn anything to cast just 1 meter as is done usually here. You cast 1 meter or 2 meter, or in 2 stages you do this column. We did not, without any problem, we casted such column. If you see this building here, you can see this tower. We cast it all one time, all height, big column, T-shaped column in this building, L-shaped column, cross column, rectangular column, walls, RCC walls. Full height 4 meters without any problem. We cast, I'm just referring to you. Same way it was done on this here, all, as well as this also we cast full height. It's quite good. So there, it's not ordinary way, and this, if you compare to those days, not nowadays, you are in 86 or 87 or 82. In 82, I dealt with concrete pumps, not mobile pumps, though mobile pumps were available, but we did use reciprocating stationary pumps, batching plants also. And still I think many additives were used in concrete that day. And we never did before, I never experienced that before in this country. I learned pumps from Iraq. I learned pumps, though I did not use pumps in Libya, but these were available. So I learned this in Doha as well as, so now it's very common, everywhere it's available. But I'm talking old time when I was only 30s and it was not available anywhere. One project manager when I was young told me, you learn it. It's better, you don't find this in our country. That was from our country. So what I say, it's a different world. When we come to engineering construction, and if it's at international level, you have to change your mindset. We have to change our mindset. We have to forget what we learned or what certificate we have. Real certificate comes from these projects. Now if you think of, if I worked on this project for about 1.5 years in structure itself. We did plastering work also, but I had to go on vacation and come back. So continuous work of 1.5 years on this building. I have told you these problems we faced, and certainly we faced. Of course, we were strict in curing work, we were strict in vibration. We did not leave any void anywhere, and we did not see any honeycombing anywhere. Some place it was seen, and some place it was not, but that's a minor one. But we had to face this problem of fascia, which we repaired by epoxy itself. And we have some honeycombing somewhere which got that time required epoxy system and applied there. So you can say on an overall basis, if you compare work quantity to errors are minimum, though I was new that time, but I was very strict in my controls, my own controls. Means I did not sit in an office as usually it happens these days. Project managers sit in office and do paper. I used to do paper additional time. You can say I could waste my 2 or 3 hours in evening or I could take paperwork with me, home and office, do from there, or no, I had to, actually I had to learn. So this, that 5 schools landscape program and this building, this project was good for me to learn in Doha. I'm talking of Doha, Qatar. And later on we learned also in other countries. I learned much in Iraq itself. And you can say I applied my knowledge in Libya, whatever knowledge I could get. That's why I said that sometimes only text knowledge is not enough for progressing in this start of 5 to 6,000 cubic meter concrete, or at least 3,000, you can say, structural concrete in 1 year. And for a young engineer is quite good. That time people used to call it a big project, because it was very bad time for civil engineers. Projects were very little, not like 60s, it was 70s, it was now 80s. So it was excellent projects, and this was not one in Doha. There were 14 such projects ongoing with different areas and different companies, and we got one for us. So I had an opportunity to do this job. Then I was given another job in the same company, and this was a part of that project actually. I'm just trying to show you that. There's a part, and if you want to see, I can show you others also if I can just find that. I think it should be somewhere here. Let me open this and show to you what I'm trying to say. And that is, I just keep in mind, or I'll forget otherwise, I was talking to you. And that is here, management documents, facilities on shore, and his career projects, photos, and this Bajania request. So yes, I got that. And here I think maybe it is sports complex. This is that complex. What's that? Bajan, second office, firing range, Bajan, Qatar. Okay, I let me say Qatar here. I think this is okay. This is, I think, PowerPoint, not PowerPoint. Let me print it out. Let me print it out, and so it will be okay. Fine, file print out and show to you what this one I'm talking about. And here is this one. You can say it's going to be printed, and I'll see in a couple of seconds. It's done, and it's coming out now. I can say yes, it's come out. So I close this file. I close this file here. So let it go. So this is that project which I got it. You see, this is that. You can see on the screen what I'm trying to show you. This is that area I'm talking about, and this is in Qatar. Again, I use Google for this. I'm sorry, Google Earth for this. And here is that shooting range I'm talking of. And here is that shooting range. This is one part of that project. This whole is that area we did work. And if you see, we have office somewhere here. This is a sports building we had there. I think this one. And there was some quarters here, and this portion, this quarter here, and there's some offices here. So we had this project with us that time. Some stadium building also there. Well, I mean, this is a big area for that area for Rayan. It is Rayan, and Grafa is Grafat written here. So it was some other road, not Alcor Road. It was a road from Grafa itself, but in the other direction. It used to go to Dukhan, and it is here. I talked of this. This was done, I said 1987. This was done. So I'm talking of this area, and you can see it's a long area, big area. And we had to walk long distances here in this portion, and this distance from here to here. And here was our office somewhere here, I think. Somewhere here it was our office. We just placed a cabin there. And this is office, squadron of, I mean, not office, this is residence, officers' quarters. And here are some squadron offices. And there was some sports here. sports complex which was to be converted from one shed to sports complex, stadium, small one, not big one, and it had some swimming pool also here. There was one swimming pool here in this, officers' quarters. So this was small size swimming pool, and 13 by 9, I think I still remember. This only for residence purpose, and this was for competition purpose. And there were so many others ones. So we can just say that it's a isolated buildings, 4 or 5 buildings together we had to work, and this was prominent one because this was for training of army. I'm talking of this one, and so I'll close this file now after saving it, because it's also important to save it for purpose of my next record. I can put there. So I'll do this later on. I can say that I don't know, method statement something. Let us, okay, I'll do it later. Okay, just different folder. What I mean to say that I'm just trying to show you in within this talk itself, because you forget otherwise what I was talking, and it's really important one. Management documents. Sorry for wasting some time, but what to do? It happens. You can say. So you can say Barshan and Iraq, and this is Barshan. So I have taken this file, I close it now for reference only. So what do you understand by that, you think? Now I've shown you that. Now what I'm going to say is that important is your concentration, important is my concentration, what we are going to do. And that's why I say coordination engineering is very important from this point of view. Whatever you do, you have to coordinate. These sketches will show you again and again. Now what I'm trying to show here is, as I said also that it's more than I should reduce it. I think it's reducible. Coordination engineering must on every project. That's what it says. I did this before also, but I repeat it because it's important from every viewpoint. It says that coordination is a must for on every project. You can say designs, construction and controls are very interrelated requirements, we can say, for every project. Starting from designs itself, we enter project world. It's not learning design, it's working design. We are going to do designs for projects which you have to do. And when designs involved means construction is going to be involved, and if construction is involved means controls are going to be involved. That's very much important. And for achieving success from design to completion, it's very important that we have to involve ourselves from each and every consideration. So it says design, construction and controls are very interrelational requirements. I'm just using different English also. For achieving from successful start to successful completion on a project, which all must be applicable throughout project stages, with all works be smoothly affected. Designs may be considered over safe or optimum, but real construction involves actual expenses, contract, time, financial liabilities and building professional reputation. These are real requirements. because we can say time is very important for contract, cost is also very important, and you can say quality is also very much important. If we can deliver project in required time, within that time, and of course cost can be changed when it is lump sum project, but even if we have to face losses, we have to deliver project. But it's good if we control cost and quality, minimum quality to maximum quality. Minimum is a limit that you have to do this, and if you don't do this, you shall not be paid, you shall not be accepted, your work shall not be accepted. So we have to keep these points into picture: quality, time and cost. And there can be added factors on this, but these are minimum. We will discuss that in separate time, separate consideration, separate involvement. When we talk of something else, we have already talked this, but we are talking now considering coordination, engineering, and I specifically call engineering. Though it is coordination, procedure of lives, but because it is a part of engineering, so we can say just like quantity engineering, planning engineering, quality engineering, safety engineering. This is coordination engineering, and we have to extract out this. We have to consider this as a subject of significance, subject of importance. We cannot simply say it's nothing. We have to realize this fact that this is a link to everyone. Coordination means we have to work in network of communication link. Communication is a force there. Communication is electric voltage there. If you have to do something successful, then coordination is a requirement in complex world, and coordination means communication is a requirement in complex world. We have to move on these two. Therefore, we can say designs come into play, and designs lead to construction, and construction leads to operation. These are chain, you can say. We have to consider design safe and optimum, but construction answers every question. Construction answers what you have decided, what you have done. So what I say, everybody wants to make money, everybody wants to earn, but important part is in construction we have to consider everything. And these points we have already given to you. I don't know, read again and again. And as I said, there are certain points here we have like introduction note we have taken, and I held with you last time also discuss about this. So I'll go to now different way. That I say if you see point 11 and point 10, you can say analysis tool can be required to operate with complete dedication to carry out or conduct controls. Analysis tool is a very important tool. It's not physical tool, it's mind tool. It's mind tool, and that tool is very powerful because mind is powerful. We have to be very specific about that. Mind tool, we cannot go without that. All required sections, related activities, import total dedication. All required sections, related activities, import total dedication. From quality viewpoint within such disciplines, in actions as well as in works, whereas all such acts certainly demand involvement of engineering coordination activities and each and every ongoing detailing review, and to ensure constructability issues. It's also very important part that we have to deliberate. You can say constructability. Again I say all required sections, related activities, import total dedication from quality within such disciplines, in actions as well as in works, whereas all such acts certainly demand involvement of engineering coordination activities at each and every ongoing detailing review, and to ensure constructability issues. And if you go further, it can be plainly said that engineering coordination is an only formula to reach workable, consistent and competent solutions. To achieve successful performance of every activity, every activity to be conducted to avoid possible delays. And these are just, you can say, guide talks. So I'm going to minute deliberation, minute deliberation, you can say. Minute I am using because I want to enter into some details also when we talk about coordination. Because for me, coordination cannot be defined with so easy statement. It varies from project to project, it varies from component to component, and it varies from standard drawings to means you have standard drawings. It depends on a smart attitude of engineer who designs, how much coordination already done or not done, and therefore it's very important from construction viewpoint. Construction viewpoint doesn't mean just design, it means do everything, and whatever we do, that must be linked together. You can see there are softwares available, you can say that softwares are available, but one software that I have and you have is natural, and that software is very important point from every point of view. And that's why we say it's really very important to understand this. And if we don't understand that, we miss a lot. So we may say minute deliberations that I'm talking about. Minute deliberation. It is something that we have to be careful about. For deliberation we are talking something logical, something very, very, you can say something very specific we have to talk about. And we have to talk about something very specific in a way that we have to do that. We can't do otherwise, it's not possible. Administration is something else, and we are not talking about administration, we are talking about coordination. Coordination is very important from every viewpoint. And if we can't coordinate, we can't do anything, you can say. We can't say anything, you can say it's a very important point. We have to be careful about. And it's my, you can say, it's my, you may say that it's my instinct, or it's my, you may say, soul also, you can say it's my soul that forces me to understand what I mean about quality and what I mean about something else. Coordination I consider also more than quality, because without coordination we cannot do anything. Coordination has been, actually, if you sleep you cannot coordinate. Coordination is that. If we sleep we cannot coordinate at all. And that's why coordination is important, and I learned it in the field. And when somebody told me you are a contractor or you are a contractor personnel, you must learn it. And they did not say what is coordination. And now they told me you have to coordinate, but see, you have to deliver work, and that's really something very important point. That you have to deliver work. You can deliver work only when you know how to do. You should know what you are going to do, and that's where you have to be smart enough. Means it's your job to do. You're not a government person. You're not in government service in India or Bharat that somebody will work for you. You have to do for yourself. And well, that point is a different one for me. That point is really different one for me. I cannot say how it is, but it's very important that we have to think of that. It's very important point of view. We cannot say no. We have to do that. And that's what I say. I respect that as well, I respect that what they say. Coordination is really important. If I refer to my experience, as I told you what my experience is, that's very important person. Means you have to be very straightforward as far as coordination is concerned, or coordination engineering is concerned. It's not simple coordination, it's a total technical work. and it should be taken care of rightly. Otherwise, we miss so much. We miss so much that we can't even understand what we have missed, and that's really important one. So I have taken some files. I close those files, in fact, and this is again I say, staff must be noticed here, and so we can close this, of course. I put up this all right. So now coordination, what I mean to say is, it's not understood by many professionals, because there's no subject. No subject exists in engineering that talks of coordination. I was watching one IIT demonstration of new designs long back, because it was referred on my SAFE that professors have done a lot. They say that you can construct a apartment in so many lakhs rupees. Those demonstrated everything. They experimented, they provided some information, but at end, that person talked of civil engineering, that person talked of designs, how it can be done. But they said nothing about coordination. And for that person, that professor commented that there should be some specialized engineer to coordinate all this. So this is comment from a professor itself, and that too from institutions of repute, international repute. Some specialist person is not available. This means that professor itself is not having a specialist knowledge of coordination. So from that day, I started thinking that coordination is a specialized subject like designs, like theory of structure, or you can say whatever else which are involved, like surveying. Coordination is also having significance, and very much significance. We cannot undervalue this, because this is multidisciplinary based subject. It's not single discipline. It involves with itself all disciplines: electrical, mechanical, civil, architectural, or you say nowadays IT, security, or whatever else. It involves that. So we cannot undervalue coordination engineering. It's a full-fledged engineering subject, but not particularly defined, because it varies from project to project. For road project, what it should be, for sewer line project, for infrastructure project, for buildings, for steel structure, and for big project, mega project. There can be many variations, and these depend on other disciplines, other subjects, other areas like quality, safety, and whatever else. Smartness of this coordination is that it is very much technically oriented, engineering oriented, and details oriented. It's not simply engineering oriented. Details, there may be hundreds and hundreds of details for some project, and those details cannot be in one go understood by every engineer. There will be many references on each details, and on drawings itself it will be written, you have to refer to this and that. That's why I said, for me, for my viewpoint, it cannot be taken for granted. It means coordination. Coordination cannot be taken for granted that somebody will do it. Who is that somebody? Because there is no reference. Who is that somebody who will take care of this? That's the viewpoint. And that somebody is not to come from elsewhere. That somebody is available here. So what I say, coordination, we have to understand first, what does it mean? It's not coordination among people its coordination on engineering projects, which doesn't mean administration, it doesn't mean only instruction, which means we have to reach solution. That's it. We have to reach solution, and we have to reach solution in time. In time. If we don't have that, we cannot do anything. That point also we have to keep in mind. So it's not simply I'm talking of coordination, I'm talking of coordination engineering, which is very complicated in a sense of concentration. You have to concentrate on ongoing activity, on activities to come, and activities that are below this ongoing activity. Those we have to understand. Each stage. And when you have drawings set with you, you have documents with you, you cannot simply sit down and sleep. Because you have to review all documents. Review. You will review all time when problems come and we have to give details, but first requirement is review of document. What does it mean? Review of documents. You are an engineer. You are a contractor. You may be organizer. You may be whatever in a responsible position. When you have a package of documents, it may be bid document or it may be contract document. Well, at bid stage you can say you have a right to demand before bid. And contract also is same, but you don't have right to because you have to do it. It depends on conditions of contract. What is your role? Now, your role is you are a coordinator, you are a coordination engineer. So when you are given this technical work, and technical work cannot be based on poems, it has to be on details. You have technical details with you. You must know at that time, after going through contents of these documents, which documents work for you and which don't work for you. And documents that work for detail running, and that's very important one. You should have a clear concept, what documents are required. What documents are required and what's are superfluous or what's are missing. If you cannot understand only this requirement, you cannot say that I am an engineer. An engineer should know based on what documents are available, whether or not we can carry out this project, we can carry out this construction. We cannot say that without having input from your files, your areas. We cannot say anything else. Whatever knowledge we have, whatever experience we have, whatever contact we have, and whatever you can say, I don't expect that somebody should come to tell you what you have to do. If you are in contracting company, your job is to deliver a project duly constructed. If you are in consultancy company, your job is to define project. So what I mean to say is, we have to know, for example, you are going to coordinate a building, what drawings you need? You need first of all that building itself. We have to see after viewing a package of documents, are these adequate? I'm not saying you have to go each and every detail that time. You may lift your cycle. What documents do we have? What sections do we have? We have to make sure Now we have to review these documents from that viewpoint. Are these adequate documents? Can we move in this document or we need more details? I'm not saying you go into depth of documents. First view them. Then after viewing you have to make sure what other documents are missing. We have to move to other page 3. Page 3 we can say we have to make sure we got all required documents. It's very easy, not a big deal, not a big deal at all. As I said, you have to do the job. You can do job only when information is available. You cannot do job if information is missing. That is also a fact. Now comes that you have got these documents. As coordinator, you keep them informed. And keep them informed means you have to know what's going to be done. Your drawings are fully aware, fully available, and there is no problem that you cannot do it. But even then there will be some details which keep on coming. Coordination is very difficult to understand, though it be coordinate. Fact always remains that without adequate and efficient coordination in professional engineering, works cannot be successfully accomplished. We said before also this. We said before this, right? And we said so many as such. What we have to define then? As we said before, I think there's some big page, right? It was very well. Whole file. I not completed this file yet, but something is there. So this is up to 28 pages only now. Now only this page. And we were somewhere on page point 50, I remember. Oh, sorry. Let's start with this point. First, let us have first review this, and then we say what to do otherwise, because other points we will take later on also. So we start with this. When it is stated, it says when it is stated about quality requirement. When it is stated about quality requirement, which indicates that quality must be used for purpose of conducting coordination. Quality must be, you can say, quality must be used for conducting coordination. It is something different, and discipline, what we say is here, you can say here something. Unfortunately, we can say quality requirement has been misled. Of course, it has been misled. Its failure has been happening by misunderstanding this discipline in its entirety, you can say. You can say that. When it's stated about quality requirement, which indicates that quality must be used for purpose of conducting coordination and discipline execution in each and every respect. Unfortunately, quality requirement has been misled and its failure has been happening by misunderstanding this discipline in its entirety. That's what I'm saying. If we combine coordination and quality, I think we can make a system. When stated about quality requirement, जब भी ज़रूरत होती है हमको क्वालिटी क्या है समझने की, हम समझते हैं हमें कोऑर्डिनेशन तो करनी ही पड़ेगी, पढ़नी पड़ेगी और डिसिप्लिन में करनी पड़ेगी, ये समझना चाहिए. When stated about quality requirement, which indicates that quality must be used for purpose of conducting coordination and discipline execution in each and every respect. It's unfortunate that quality requirement has been misled and its failure has been happening by misunderstanding this discipline in its entirety. Quality works in each and every discipline in life as well as in every profession, whereas engineering is no different. Quality must be used as a requirement on all works in the word of quality and coordination. Coordination also must have quality. This means it's not simply coordination, and that quality is bad position. Quality works in each and every discipline in life as well as in every profession, whereas engineering is no different. Quality must be used as a requirement in all works, including works of quality and coordination. Factually speaking, individual's quality is known by its professional personality. Efficiency achieved about degree of work or production. Quality one possesses, and then further assessment can be calculated or charted out to know its level of work and specifically coordination competency attained by individual professional. No way exists that quality can be achieved proficiently without working on expert coordination. For doing right work, time. We may say no way exists, or before that we can say, just a minute, let me finish this paragraph, it's missing, let us see if I missed something. Factually speaking, individual's quality is known by its professional personality, efficiency achieved about degree of work or production, quality one possesses, and then further assessment can be calculated on, charted out to know its level of work and specifically coordination competency attained by individual personnel. No way exists that quality can be achieved proficiently without working on expert coordination for doing right work, first time, every time, and controlling use of every and every now. No way exists that quality can be achieved professionally without working on expert condition, coordination, for doing right work first time, every time, and controlling use of each and every resource for optimum use. You know this, what does this mean? It's not very specific but important one. We have to work proficiently. We can achieve quality, we can achieve coordination, and quality can be achieved proficiently. There's no way out. We can do it without working on expert condition for doing right work. So we repeat, no way exists that quality can be achieved proficiently without working on expert coordination for doing right work first time, every time, and controlling use of each and every resource for optimum use. Is it, you can say, certain points that are required to be discussed, certain points required work activities, certain points are required to be discussed for purpose of project executions or prosecution, or one item, one can call it organization handling, respecting construction work activities in both disciplines of site work as well as coordination, without which work cannot be completed in now. For this purpose, first of all, I say certain points that are required to be discussed for purpose of project execution, so prosecution of one can call it organization, handling, respecting construction work activities in both disciplines of site work as well as coordination, without which works cannot be completed in each and all respects. For this purpose, they attempted to write certain points herein so that one could get an understanding about works, requirements in profession of building, construction, as well as plans, facilities or processing plants, construction, which points certainly details out of line to follow of required works. I collected and included these points in one book from long back. In one book long back in 92, 96. It has been too long. The works have been not changed in terms of quality and coordination, despite availability of the digital world everywhere. Let's consider these points given below, following points and activities. At certain works to be carried out on sites and elsewhere, or we can classify this into certain these points that we are going to discuss these points are very important, and we can classify these into certain classes or can call them stages of project working. Visualization of an idea is to be converted into useful permanent work. Technicalities involvement in its entire scope, carrying works at site, you can say all works, and in testing and commissioning, or you can say technical and commissioning for converting projects into operational unit or acquisition line unit. Foregoing prefaced points are required to be exploded into world of explanation in various heads and subheads, working out comprehensive designs for project in each and every respect. Designs include architectural details, structural details, service details, internal and external landscape and utilities. These are general. Architectural, structural details, services, internal and external landscape, utilities. These are generally common. Very common this. What is this? So this paper which I am stuck in, for your explanations, actually I want to give you a chance to read this before we go on discussing further. So I say architectural details, structural details, service details, internal and external landscape and utilities, and this is particularly for buildings project. particular for buildings project as shown to the sketch Amsalal. All details are there available or to be reverted to. And not yeah, answer this. Then we see preparation of working out designs or designs for running relevant details in all disciplines also required for various legal purposes. Composition of formation of documents package for purpose of either charting out calls for bidding invitation or for self doing their works. Preparation of bills of quantities for each discipline is cumbersome. So we can say preparation of working out designs for running relevant details in all disciplines also required for various legal purposes. Composition of formation of documents package for purpose of either charting out calls or bidding invitation or for self-doing these works. Preparation of bills of quantities BOQs for each discipline is very much necessary. Once all designs are finally available and accuracy at this stage much help in starting various controls on schemes or projects. Preparation of all required documents to be included on bids for allowing construction expert to work out respective practice price to implement project to success. Preparation of all required documents to be included on bids for allowing construction experts to work out respective price to implement project to success. above, among above structural part of documents. Sorry. Among above structural parts of documents and finishes part of architectural as well as other activities dominate cost factors that can be marginalized by BOQ and decided, required and demanded specifications pertinent all disciplines involved. Indeed, Indeed, aforesaid expressive heads amount to voluminous work, quantum, but it is necessary for every control on construction time, duration period, duration required, cost necessary, and standard of quality requirements which could be dominated by sort of specification to be included. What we have learned from this so far in this case of 4 or 5 paragraph, what does it say? Actually, it relates to architectural details, structural details, services details, internal and external landscape and utilities. What actually in common sense we want to say? In common sense we want to say that details on cannot move. We require architectural details completely. That point must be clear. And we also require structural details integral. We cannot say so. Architectural details means these should be clear. These should be very clear without any ambiguity. We cannot simply think that it's fine. We have to think that it is worth working, not fine alone. Worth working. It should bring job to reality. And in alliance to that, in coordination to that, structural arrangements, structural designs, structural presentation should be all the life. Designs, as I said, architectural and structural, are very important towards realizing construction. These are dominant factors, architectural and structural. If there is an error in architecture, same error should come in structure. It doesn't happen. It doesn't happen. These two dominants, architectural and structural, make project. Inserted between these are services and vicinity based internal and external landscape, and hidden below are all utility services. Very important points I'm discussing with everyone, because you cannot deliver projects if you don't understand these points. Even sometimes, experienced engineers also lack in certain way. Architectural drawings should tell everything to structural engineer what is required. What are given levels, what are different levels, what is track, and what quality of water we are doing. 1930 onwards. So what we have to think of this now? We have to think a lot. It's not speak only. We have to think how to fit in both. There can be errors in both. Indeed, there can be errors in both. How to take out this error? This is out. I'm still pointing to architectural and structural details because I discovered in my career there's these two pose problems. Reason being, architect does not care for structure in real world, and structure in air does not care world by designing about architectural division. So they both have drawings, or don't have drawings, I can't say, but don't bother about that. They should not bother with that. It's visual only. What we have to consider both together along with services. When we have thoroughly checked these drawings, related this drawing to each other, we finally trace what is missing or what is not missing. And if something is missing, it is to be inserted again. Clashes may be there. Clashes, what clashes? Services clashes or self clashes. Services may run in dry walls or in floors or in elsewhere. Composition of formation of documents package for purpose of either charting out calls for bidding invitation or self doing these works. That is important to decide. It is very difficult to decide, in fact. No engineer would take risk. That's also true. Owner has to take risk these days. Why? This is to be done by contractor. These are optional questions. What shall you answer? You can see yourself. Composition or formation of documents or bidding is very important part. It's not just documents to give. You have to plan your sequence in a way. It's an important point here we are discussing, very important point. Documents for charting out contractors' job. It's very important point. What should contractor do if your documents are not complete? That is point I want to direct, I want to note. How can contractor be helped? Now, preparation of bills of quantities for each discipline is very much necessary. Once all designs are finally available and whatever accuracy of this stage, accuracy at this stage much helps in starting various controls on scheme or project. Preparation of all required documents. Preparation of all required documents to be included on bids for allowing construction experts to work out respective price to implement project to a success. We can say again, I say, it's important part, preparation of all required documents to be included on bids for allowing construction experts to work out respective price to implement project with success. Among above structural part of documents and finishes, part of architectural as well as other activities dominate cost factors that can be marginalized per POQ and decided, required, and demanded specifications pertinent all disciplines involved. Indeed, these expressive heads amount to voluminous work quantum, but it is necessary. It is necessary for every control on construction time, duration required, cost necessary, and standard of quality requirements. It should be dominated by sort of specifications to be included. Initially, all foregoing activities, though conducted off-site in offices of experts, the major portion relates to design engineering domain and quantity engineering, also called estimation. Designs within this stage must be coordinated correctly to an extent possible among various disciplines, say between architectural and structural disciplines, structural and services disciplines, and all other disciplines what are being involved. Total concept of constructability. Buildability must be taken care of during all such designs and respective coordination. All such designs and respective coordination, if ignored, would mar smooth execution possibility of project work. Activities resulting in certain delays on completion time. Constructability is dominant issue in current advanced technology applications. Constructability is a dominant issue in current advanced technology applications scenario, which of course lack in training at first level of education. Constructability is a dominant issue in current advanced technical application scenario, which of course lacks in training at first level of education. It should be kept in mind that engineering is a factual world and no fiction can be successful, which means that just talking is not adequate, but work, delivery, implementation is necessary. And for meeting aforesaid requirements, in lot professional maturity is essential to comprehend whole issue that relates to works to be carried out by various either agencies or parties involved on every project, from conceptual stage or conception stage to design stage to construction stage, and then finally to delivery stage. Give me a few minutes, please. see what is there. So we were talking of activities regarding this, and such activities entitlement can be described in heading forms as such, which may be indexed in entirety into a division of responsibilities, and that is what we are talking about here. Activities that are important for works, projects generally are as follows. We can say it's not very difficult. In fact, everybody knows about this, but just we are going to index in to let you know what we have to consider about for general projects. We can say, in fact, project planning, explanations of planning classes. You may say that. You have to plan something, you have to explain that one. What do you plan? A plan doesn't mean scheduling here, I mean to say. We have to plan in a gross way. It's different type of plan. Project plan. Not activities based, different one. We may say project planning, entire design involving all disciplines. That is first requirement. After project is accepted, I mean to say, when budget is available, something is available, we have to say entire design involving all disciplines, pertinent all branches of job, included engineering whatsoever. Detailed designing per project function requirements or purpose of furthering documentation that may be required for meeting objectives of formation of formal what? Contracts and working documents. Contracts or working documents, you can say. These designs, whatever we do, have to be converted into certain documents which speak in itself. Contracts or working documents for purpose of contract. Working documents for purpose of contract. Quantification leading to various bills of quantities. That process, you can say, is quantification. That leads to formation of various bills of quantities, preparation, specification, preparation, which could be generally as well as project related specifically, particularly, as well manufacturers related procedures. Wise, can say process comprehensive package of bidding document. Processing comprehensive package of bidding documents. Shortlisting possible project related experienced bidders. Processing entire bidding leading to selection of contractor after having conducted thorough scrutiny of received bid documents, pass through professional competition. Furthering, if required, conducting negotiations based on value added bids or and also received an alternative bid. Formal declaration of appointment of contractor. Formal declaration of appointment of contractor, which could be either in construction time, construction status, or in APC status, depending on requirement. These foregoing immediate paragraphs I refer to contents give or fulfill pre-construction of project execution requirements, which are of course very cumbersome, since all involved activities are office oriented but import heavy requirement of professional working experience. and professional pragmatism for a successful impending contract documentation based on bid documentation. Here we can say we are concentrating or we are focusing on very initial stages of project policy decisions, who has to do what and who shall lead what. That point really is very important for future of that project. And if we miss this point in our work, in our strategy, though it's at higher level of project, it's not at lower level. It is something that at very junior stage of profession, we may not imagine that, but it is very important in every respect. We cannot miss that. We cannot afford to miss that. And that's very important point in our profession. We have to care about that. We have to care about that. I hope we'll meet again, for this time is over and I don't want to take more time because of little bit, not limitation, but it's not just to go more and more. I hope you got it and we'll take care of this. So hope see you again.